I'm Stephen Foskett here at NetApp Insight, and we are pretty excited that we just saw a new generation of NetApp storage systems announced today. The AFX is NetApp's latest, greatest, all singing, all dancing, really honking big storage array. And I am joined here by Keith Asen, who is the product manager for the AFX. Welcome, Keith.
Thanks for having me. I'm pretty excited to be here.
You've been working on this thing for a little while, right? You finally excited to see it on stage?
A couple years now, and it's really weird to see it out on stage. It felt like sending your kid on the first day of school, right? As now he's out there and hopefully everybody likes him.
Well, I got to say, right off the bat, I'm a longtime NetApp customer. I was actually one of NetApp's first customers, no kidding, back in 1997.
Wow.
And one of the things NetApp has always done is beautiful bezels. You got one, man.
Yeah, it looked pretty nice in that rack. I have to say, it was a little bit of work there, and yeah, it doesn't hurt to look pretty in the storage world.
Do you have one on your shelf?
Not yet. None.
You got to steal one from manufacturing.
Oh, I do. Maybe I'll go home from the show with one in the suitcase.
So tell me a little bit more. So the AFX, as I said, is basically the biggest, baddest storage system NetApp has ever built.
Absolutely, without a doubt. You know, a order of magnitude bigger from a throughput standpoint and a capacity standpoint, and it's ready for whatever AI is going to throw at organizations.
And whatever AI is going to throw at organizations, as we heard, of course, is data, and lots of it. And those of us who've been involved in AI in the enterprise have seen that one of the challenges is random access, multi-client access, and throughput. And it seems like, even though to the front end it looks a lot like a NetApp ONTAP filer, I don't know if you call them filers anymore. I still do. I still call them toasters. On the back end, it is totally new.
That's it, spot on, actually. Yeah. So the data management layer, the thing that makes ONTAP so popular and you know so strong for enterprise, is all intact. But you're absolutely right. We managed to sort of rebuild the house underneath to change how we manage storage and how the cluster connects with itself and how the cluster scales out. So, you know, on the surface, customers will find things very similar, very comfortable. But what it can do from a performance standpoint and throughput standpoint, a whole new beast.
So let's dive into that. So number one, you've got the AFX head unit,
yep.
controller, and those are basically a scale out architecture, and the storage scales up below them, right? So it's up and out.
Yeah, they look and feel a lot like our other storage controllers. One difference is they have internal boot media. So one thing that's changed is it boots ONTAP for the internal boot media instead of off of shared disk. And that allows ONTAP to boot and then join into the cluster. Now, as soon as it joins into the cluster, ONTAP then goes, hey, I've got more resources, and will automatically load balance and start adding more workloads immediately to those new nodes. When I add new shelves, we bring those online, and ONTAP automatically scales those shelves, and all controllers have access to all shelves. So it's a full meshed fabric. Any workload can run on any disk or run on any node.
Now, ONTAP has always been good at scaling up. That was one of the reasons that, as I said, we bought it many, many years ago, because we could buy some now and add some later. But the problem is scale up only gets you so high, right?
Yep.
And now for a long time, NetApp has been working on scale out. Give me the big number. How big can AFX scale out?
We're launching here with 128 nodes, and that's not an architectural limit. That's just, for right now, we don't expect anybody to need more than that. But architecturally, it can scale out much beyond that. So from our previous limits of 24 nodes, that's a pretty dramatic shift. And the fact that workloads are never trapped on any HA pair. A workload can move around in the cluster when or if needed.
Yeah, that's a big differentiator here, right? So that essentially the workload is sort of fully virtualized in that the client accesses the cluster decides which node, which disk shelf, where to put it, and it can dynamically move that stuff around to adjust to the demands, right?
Absolutely. We refer to it as copy-free migrations or zero-gravity migrations. And it happens periodically as the cluster is running, so making sure that no node ever runs out of compute resources. We can move things around and avoid that. But it also happens when you add new nodes. So we make sure we take advantage of those new resources right away. It also happens if you have node failures. So as soon as a node fails, we can then take the workloads that were running on that node and distribute them across the cluster. So it starts to uncouple this concept of an HA pair. Now, we still add nodes in pairs for now, but the data is not trapped and the workloads are not trapped on those particular two nodes.
Yeah, so you have a really flexible. And what this means, I think, is that as you get a lot of these nodes working in concert, maybe not 128, but a whole bunch of them working in concert, then if one needs to be taken offline, I don't want to say fails, because they're not going to fail, right?
Never.
Never. That would never happen. So if one needs to be taken offline or whatever, or if one is added, the customer doesn't really have to worry about it because the performance, probably isn't going to suffer at all noticeably because you've got so much resources in that cluster.
Yeah, and one of the things that's quite different on AFX is how the level of automation we've put into it. So you're not having to make those decisions is when a node goes offline or when you take a node offline, the cluster automatically finds the optimal places to place those workloads. When I bring a new cluster or a new node on, the cluster automatically determines what workloads are best to place on there. In fact, if you set up the cluster in such a way where you provided a pool of IP addresses, it'll automatically stand up all the data lifts, right, all the connectivity for that new node. So actually adding nodes is so much easier in AFX.
And under the hood, obviously, things have gotten a lot better since those big, bulky SCSI cables from the past. This is all Ethernet. It's all switched. And there's almost an any-to-any relationship, right, between disk shelves and controllers.
Yeah, absolutely. It is all industry standard, 100 gigabit Ethernet. We're selling it with Cisco switches, and they're new 400 gig switches. Really helps simplify and increase the density of that switching. And one other major change is versus our AFF that you may be familiar with, had a cable that we would do the HA across that. Now everything is tied into the switch. So whether that's cluster communication, whether that's communication to the disk shelves, or even the HA mirroring of the NVRAM, all of that happens across those Cisco switches in the back end.
And that seems to be sort of a theme here, in that what you've done is you've done away with a lot of the sort of proprietary and, but we actually need this kind of, and there's no more, but we actually need this. It's connected to a switch, and the switches are connected with 100 gig, and we've got plenty of bandwidth, and you can just build something huge.
If you need it. That's the thing is actually the starting configuration is not that huge. Starting configuration is 4 nodes and 1 shelf of disk. So it doesn't have to be huge, but from that one configuration, I can start adding nodes, or shelves, and I can reach that exact scalability point that I need without wastage. I'm not having to add capacity just to get the performance.
But capacity and performance, you can scale very, very high. So, I don't know, what are the highlight numbers for throughput and for capacity?
It's mind-blowing to be thinking that I'm talking about throughput in terabytes per second, but that's absolutely where you're getting to is the terabytes per second, both reads and writes. And then from a capacity standpoint, depending on a hot versus a tiering, well over an exabyte. So I think on the stage today, they talked about exabyte scale, over an exabyte if needed.
And it sounds like it could probably go bigger if you added more than the 128 nodes and more disk shelves and everything, but so far you haven't gotten there.
Exactly. They're not architectural limits. One of the things is when we did this re-architecture for AFX, we wanted to make sure we engineered it for the future. We didn't want to have to do another re-architecture in ONTAP. And so it can go bigger, but those are the limits we're launching with because I think that's going to cover pretty much all the workloads out there, or most of the workloads out there.
It's going to cover a lot of them,
yep.
And even the AI workloads that get very, very big. Now, one of the things that I think we should talk about is the front end, because one of the challenges for AI workloads is that you have really high levels of parallelization of access to data. In other words, there are many, many nodes, many more than we're ever seen before, accessing sometimes the same data, sometimes accessing completely different data, just a real I/O blender going on the front end. And you've built this thing for that use case as well.
Well, it does have a full set of protocols on it. So we do support SMB, we do support S3 protocol. So we are seeing training and inferencing even being done on S3.
Yep.
But then NFS, we do support NFS v3, but primarily the sweet spot is going to be NFS v4 with PNFS. And that's been out as an industry standard for a while, but it's really reaching this sort of scale where I have a cluster that needs that sort of capability. And when you couple PNFS with that ability for ONTAP to move workloads around and then report back to the clients what's the optimal path to that data, super powerful combination. And that gives us parallel file system-like performance without actually having all the headaches of a parallel file system.
Yeah, and also PNFS at this point, I know that storage nerds like me have been waiting for it to come alive, but PNFS at this point is extremely widespread on the client side. In other words, most clients are PNFS ready, right?
They are, absolutely. And the other thing that's happened in that same time is the performance delta between NFS v3 and v4 has narrowed right down, right? So a lot of people are like, yeah, I like the functionality of v4, but I want the raw performance of v3. That performance delta gap has narrowed right down. And with PNFS, you get that incredible scalability and optimal pathing.
So moving up the stack a little bit then, so obviously this is going to be used in AI training. It'll probably also be used in the sort of heterogeneous AI applications that we heard about on stage today, and basically at every event that I've been to this year where we need to basically present data. NetApp also talked about an AI data platform and AI data classification. How does this AFX fit into that overall picture of AI data readiness?
It's the foundation. Right, so it's powerful in what it does, and for some customers, that's all they need is the foundation. But for those of us that are moving, the next layer is the metadata engine. They referred to that, and the metadata engine plugs seamlessly into AFX to give customers a searchable catalog and browsable catalog of all the data that's consuming space in that cluster. And that can be just for show back or charge back or just what's consuming the space on my cluster. But also that is where you start to curate and understand what data do I have, where is it, and how could I use it for AI. And then on top of the metadata engine is where we use the APIs from that to apply the advanced AI services.
Mm-hmm. So essentially, this is really the foundation of everything that NetApp announced today. Now, it doesn't have to be, though. I mean, this is absolutely useful in a variety of applications. But if customers are looking for a system that can just scale to really massive proportions, that can scale performance, that can handle the kind of parallel access that you're going to find in AI training scenarios, AFX is it.
100%. And as you mentioned, we're bringing those advanced services to the whole ONTAP because this is still ONTAP. We didn't fork the code. That's an important thing to call out too. This is still ONTAP. This isn't a separate build or a separate set of APIs. It's still ONTAP, but it does give that massive scalability. But you're absolutely right. We can take that data elsewhere in the portfolio.
Well, this is great. I'm really excited to hear about AFX. Again, I'm a longtime follower of NetApp. Very exciting to see how you're taking the platform forward, how you're taking ONTAP into the future. We'll be learning more about this during our Tech Field Day sessions here. We'll be live streaming those on Thursday and then, of course, putting them on YouTube. If you're watching this after the week of NetApp Insight, you can find all of these videos on YouTube. Keith, thank you for joining me. Thank you for giving me this little behind-the-scenes peek at the development and the launch of AFX.
Thank you so much for having me. Thanks for coming to Insight, and we're super excited to share this with you.